In this tutorial, we will practice setting up a load balancer. However, before we dive into that, we need something to direct traffic to. So our first step will be to create two EC2 instances. Let's begin by navigating to the EC2 dashboard and clicking on the option to launch new instances. On the right-hand side of the screen, we can specify the number of instances to launch. Here, we will select 2. I will name the first instance My Instance 1. We'll assign a name to the second instance later on. For our operating system, we will be using Amazon Linux 2, which is a solid choice for many applications. We're going to opt for the T2.micro instance type, which is perfect for our testing purposes, especially since it falls within the free tier for eligible accounts. Next, we'll continue without including a key pair, as we won't require SSH access for this example. However, if the situation demands remote access later, we can utilize EC2 Instance Connect for secure connectivity. Moving on to the network settings, we'll choose an existing security group that we've designated earlier. Specifically, we'll select the Launch Wizard 1 security group, which is set up to permit both HTTP and SSH traffic to our EC2 instances. This setup is ideal for our needs. Now, we'll proceed with the default storage settings. In the Advanced Details section, we'll scroll down to add some EC2 user data. I have a script prepared, which I will copy and paste into the designated field. This script will configure our EC2 instances automatically upon startup, ensuring they are set up as we expect, similar to previous instances we've launched. Let's go ahead and launch these 2 instances. Once they are being created, we will check on all instances by navigating to that section. At this point, I'll rename the second instance to My Instance 2 and click Save. Now, let's allow a moment for these instances to initialize. Once they are up and running, I'll copy the IP4 address of the first instance, paste it into my web browser, and hit Enter. Immediately, I see a Hello World message displayed from my instance, which indicates it's functioning perfectly. Next, I'll repeat this process for my instance 2. I'll grab its IP4 address, paste it into the browser, and press Enter. Once again, a Hello World message appears, confirming that both instances are active and responsive. This means we now have 2 instances that each return a Hello World message. The final step involves consolidating access to these EC2 instances under a single URL, which will also help distribute the traffic evenly between them. For this purpose, we'll implement a load balancer. Let's navigate down to the Load Balancers section, where we can create a new load balancer, enabling us to efficiently manage incoming traffic. Today, we'll explore various types of load balancers, focusing specifically on the Application Load Balancer, ALB, for our demonstration. It's essential to distinguish between the Application Load Balancer, the Network Load Balancer, NLB, and the Gateway Load Balancer, GWLB. Starting with the Application Load Balancer, designed to handle HTTP and HTTPS traffic, it optimally routes web requests to your applications. In contrast, the Network Load Balancer is geared towards TCP and UDP protocols, including TLS over TCP. This type of load balancer is ideal when you require exceptional performance, capable of managing millions of requests per second with minimal latency, making it a powerhouse for applications where speed is critical. Next, we have the Gateway Load Balancer, which serves a vital role in security. It is used for tasks such as intrusion detection and firewall functions, effectively analyzing network traffic and ensuring that your infrastructure remains secure. As we move on, it's worth mentioning the classic load balancer. However, This may soon become obsolete, so we will not focus on it in our tutorial. Now, let's dive into the process of creating an application load balancer. We'll name our new load balancer Demo ALB. For those interested in the intricate workings of load balancing, further reading is available, but the previous lecture should provide you with a solid foundation. This load balancer is designed for internet-facing traffic and will use an IPv4 address. When it comes to network mapping, we need to select the appropriate availability zones for deployment. It's a good strategy to deploy across all available zones for enhanced resilience. Next, we will assign a security group to our load balancer. I'll create a new security group specifically for this purpose, named Demo SG Load Balancer. This security group will be configured to permit only HTTP traffic. In the inbound rules, we'll allow all HTTP requests from any source, ensuring that users can access the ALB without restrictions. The outbound rules can remain unchanged for now. Let's proceed to create the security group. Once created, I will refresh the page and ensure that the Demo SG Load Balancer is selected, while removing the default security group to maintain a clean setup with just one security group in use. Let's scroll down and continue configuring our load balancer. Now, we're currently focused on the section regarding listeners and routing. To successfully manage the traffic, we need to direct SHTTP requests over port 80 to a specific target group. A target group essentially consists of a collection of EC2 instances that you have previously set up. To initiate this process, let's go ahead and create a target group. Click on the appropriate button to start. In the basic configuration settings, our aim is to cluster the instances together. Additionally, you'll notice that there are several configuration options available. For our current setup, I am going to name this target group Demo TG. We will be using the HTTP protocol on port 80. While there are various protocol options, selecting a different one will imply compatibility with different types of load balancers, so we will stick with HTTP on port 80. The version of HTTP we are using is version 1, so let's maintain that setting. The health check parameters are suitable, so we can move on by clicking the next button. Next, we will proceed to register our targets. We need to include both of our EC2 instances, configured to listen on port 80, and we will acknowledge them as they appear below. At this point, our instances are now registered, so let's create this target group. It has been successfully created. Now, I should refresh my page since I had previously set up a target group. The one I plan to use is Demo TG ALB. This target group is now successfully created and is associated with the listener on my load balancer at port 80. We are now ready to advance and set up our load balancer. I'm going to click on View Load Balancer to revisit the load balancer page where I can observe its current status. Right now, it is in the provisioning phase, so we'll need to wait until it's fully provisioned. Great news! My application load balancer, ALB, is now active and fully operational. As you can see, there is a DNS name generated for me. Let's copy that DNS and open it in a new tab to test it. By doing this through the application load balancer, I can expect to receive a Hello World response. An exciting feature of this setup is that if I refresh this page multiple times, I'll notice that the targets being displayed are alternating. This behavior occurs because my application load balancer is intelligently distributing the traffic between both EC2 instances, which highlights the effective load balancing in action. and that's our confirmation that the load balancing is functioning correctly. How can we further verify this? All right, let's navigate to our target group and examine its targets. As you can observe, both of them are currently in a healthy state. This indicates that the application load balancer will effectively distribute incoming traffic between them, alternating between the two. The load balancer operates intelligently, ensuring optimal resource utilization. For instance, if I take the first instance and stop it, we'll see a shift in the operational status. Essentially, we are halting both instances, which means that the first instance will become unhealthy since it can no longer process incoming traffic. If we access our target group and possibly refresh the page, we should wait about 30 seconds to allow the status change to register. Now, if we check again, we'll notice that the first instance is marked as unused because it has been stopped. Returning to our application load balancer and refreshing once more, we can see that the only responses we are receiving pertain to the instance that remains operational. This highlights the efficiency of load balancers. They can accurately determine whether a target is healthy or not. Now, if we decide to recover our stopped instance and start it again, it will go through the boot-up process and re-establish its service behind the scenes. Let's give it a moment to initialize, and hopefully, we will soon see it reflected as healthy within our target group. The instance is now running, and we're observing the initial health status. Look at that! It's transitioned to a healthy state. The load balancer has recognized the instance as healthy once again. Checking back with our application load balancer and refreshing, we can confirm that the Hello World response is now being served from both instances. And there you have it. We've successfully implemented a load balancer, configured it, and added 2 targets within the target group. Let's dive into some advanced concepts regarding our load balancer. First, let's explore the vital aspect of network security. Currently, we manage access to this load balancer using a specific security group, which you can see designated as My Load Balancer Security Group. Our EC2 instances also operate behind their own individual security groups. If I examine the public IP and attempt to access it directly, you'll notice that I can reach my EC2 instance without any obstacles. Alternatively, I can also connect through our load balancer. However, it might be more secure and efficient to limit access to the EC2 instances strictly through the load balancer. So, how can we enforce this restriction? Let's navigate to the Instances section and then select Security Groups. Here we will focus on the security group named Launch Wizard 1. Within this group, it's essential to modify the inbound rules. Currently, the rules here permit traffic from any source to our instances. But what we want to implement is a rule that restricts access such that only traffic originating from our load balancer is permitted to reach our EC2 instances. To achieve this, the first step is to delete the existing rule that allows universal access. After that, we can proceed to create a new rule. Here, we'll maintain the HTTP protocol, but instead of entering a CIDR block to define the allowed IP ranges, we can see an option to specify security groups directly. To simplify this process, you can start typing load in the search bar to filter the available security groups. Select the security group corresponding to your load balancer from the filtered list. By saving this new rule, we effectively update the security permissions for our instances. Now, if we revisit our EC2 instance directly and refresh the page, you'll see that it's timing out. This indicates that direct access is no longer allowed, as we've configured the security group to block it. However, if we refresh our load balancer, you'll observe that it can still communicate with the EC2 instances seamlessly. This is possible because our newly created security group rule permits inbound traffic from the load balancer's security group, ensuring that it can still manage and route requests effectively to the instances behind it. By implementing these security measures, we enhance the security posture of our architecture while still allowing the load balancer to function correctly, demonstrating an important practice in cloud infrastructure management. In this segment, we will be focusing on enhancing our network security protocols. Next, I'd like to introduce you to the configurations for Application Load Balancer, ALB rules. Let's take a look at our current ALB setup. Here, you can see the options available under Listeners. I'll click on that section to navigate deeper. As displayed, we have our listener configuration right here, complete with various details. When I scroll down, you'll notice we come across the section dedicated to listener rules. This is where we can implement new rules to manage how requests are handled. Currently, we have a default rule in place that directs all incoming requests to our demo target group associated with this ALB. However, the beauty of ALB is its flexibility. We can add intricate rules tailored to our specific requirements. Let's create a new rule, and I'll name it Demo Rule for clarity. The next step involves setting the conditions. Conditions essentially allow us to filter requests based on certain criteria. For instance, we can examine host headers to see if a request is coming from particular subdomains, such as star.example.com or myapp.example.com, depending on your application needs. We can also define the path criteria. For example, let's specify that if the path includes /error, this condition should trigger our new rule. Additionally, we have the capability to choose the HTTP request method, such as GET or POST, along with filtering based on the source IP address or even specific query strings and HTTP headers. This versatility allows for a highly customized rule setup. For the purpose of this demonstration, I will select the path condition and enter /error as our trigger point. Let's confirm this setup. It's worth mentioning here that we can include multiple conditions if necessary, depending on the complexity of our setup. You can also check the current limits for rules to ensure compliance with your design. Now, moving forward, we just need to specify what action to take once our specified condition is met. For instance, should we forward the request to a particular target group? If we have multiple target groups set up, we could determine which one to utilize based on the path or the host domain. Alternatively, we might want to redirect the request to a specific URL. When redirecting, we can define parameters such as URI parts, complete URLs, the communication protocol, whether HTTP or HTTPS, and even specify a corresponding status code for the operation. Additionally, we have the option to customize the host, path, and query as needed. Stay tuned as we continue to explore the capabilities and configurations available for our application load balancer, ensuring it operates efficiently and securely. Alternatively, we can generate a fixed response, which is exactly what I will demonstrate now. We'll configure our message to say, "Hey 404, it's not found." This custom error response will be displayed whenever we navigate to the /error path. You'll grasp its functionality shortly. Next, let's discuss the priority of this rule. Currently, its status is pending. In our system, we can set up numerous rules, potentially up to 100. Each rule can be assigned a priority level. The highest priority is represented by the number 1, with subsequent numbers indicating lower priorities, extending up to 50,000. This prioritization is crucial because if multiple rules match a condition, the one with the highest priority will take precedence. For demonstration purposes, we'll assign a priority level of 5 to this rule. Now, let's review our listener rules. Once we click on Next, everything appears to be in order for this demo rule, and it has been successfully created. We can now observe that we have two rules in place. The default rule and our new demo rule. Additionally, you have the option to add more rules if desired. Now, it's time to test our configuration. I'll access my load balancer details, locate the DNS name, and append /error to it. By doing this, we'll activate our rule, which should yield the custom error message, "Not found." This indicates that the request successfully matched the path pattern of /error, resulting in a 404 response and a plain text output. And that wraps up our demonstration. I hope you found this tutorial insightful and engaging. Looking forward to seeing you in the next lecture.